Today on China Talk, the Chips Avengers have assembled. We have here today Reva Gujan from the Rhodium Group, Jay Goldberg of Digits and Dollars, currently raising a chips investment fund.
Deep
Uh,
deep tech venture fund. Yep.
deep tech venture funds. We have Doug O'Loughlin, author of the Fabricated Knowledge Substack, and Martin Chorzempa of the Peterson Institute and recently published Cashless Revolution, here to unpack what the Biden administration's export controls mean for the future of humanity. Thanks so much for coming on China Talk, everyone. So for this episode, we are going to assume knowledge that you will have gained as an audience if you listened to my interview with Kevin Wolf a few weeks ago. So if you haven't listened to that, I would pause this show and then come back here for this conversation. Let's get normative for a second. Was this the right thing for the Biden administration to do? And if we don't want to, come to an answer to that, what do you think are the kind of factors or analytic questions that you would need to answer in order to come to a judgment on whether or not these policy moves were, the right in retrospect?
This is Jay Goldberg. So I think right is a difficult word to use. I think it's a little provocative, deliberately, I would guess. But my question is, right for what? And one of the things that I've really puzzled over since these rules have come down is, what is the government really seeking to achieve? How narrow or how broad is the scope of this? I mean, the scope is very broad. Was that the intent? What's the end goal? And I think certainly some things are going to work very well. Other parts of it, I think, are going to be very problematic. And so if we talk about right, I think we need to sort of establish what the goal was. And I know that's a tricky question. I don't know that there's an answer to it, but it's tricky there.
Yeah, Jordan, this is Reva. I am hesitant to jump into the normative just because I have to always start with the why, right? And what's really driving such a comprehensive package of controls at this juncture. And I think one layer of this, of course, is the strategic competition element, right? And as the U.S. is scanning China's strengths and weaknesses, where does it have leverage over choke points? Where can it really hit hard? And I think some of the real novelty in these controls showcases how it's concomitantly narrow and broad, and very deliberately so, right? In what it prioritizes and where it goes very broad and saying, we want to know what inputs are going into China, period. And companies are just going to be subject to U.S. licensing as a result. But there's also another layer here on the why, which is petty politics as well, right? When we look at just the political drivers of, trying to outmuscle one another on China policy and really set the bounds for this debate, because there are lots of, while China, can be a very bipartisan issue on one level, on another level, the tactics, you can see a lot of variance, right? A lot of proposals of how a new export control regime should be structured. And so here's the White House coming out ahead and saying, well, these are the technologies that matter. These are the thresholds that we're going to define. And these are the tools that we're either going to adapt or create anew, which is what I think creates some really interesting implications ahead.
Yeah. Martin, maybe you want to take a step back and talk about, what is the strategic direction of all of this? And does it make sense to you?
Sure. So, the signaling for this really goes back to Jake Sullivan's speech a few weeks ago, where he said, specifically on export controls, we're no longer okay with being a generation or two ahead. We want to be much further in foundational technologies like chips. And so if we're thinking about the goals of this, I think there's been a shift away from trying to freeze or hold back China's advances in chips. And I see this as an attempt to roll back and degrade China's existing capabilities. China can produce 14 to 16 nanometer logic chips. BREN can produce, GPUs that are at these thresholds. And YMTC can produce NAND at the levels of this threshold too. So what's very interesting is that they did not set the thresholds at kind of an aspirational level for China. They set them for levels that China already is able to do, and it's cutting off their ability to do it. And that's what raises all sorts of really interesting questions about unintended consequences, where you might have a lot of American equipment in those fabs that might be bricked. It's hard for me to tell, trying to parse the regulations, if it's going to be possible for the technicians to be in there continuing to maintain these machines. And the fact that China is already at this level tells you that the Biden administration saw that this was a bit of a rush. They felt like they had to do this now, because otherwise maybe the insert your metaphor about the cows leaving the barn and not being able to put them back in again. And that we're only going to see the impacts of this playing out over a while. We're not going to be able to tell right away.
So staying at that question for a second, is I want to set the should the US compete with China piece aside for this conversation at least. But if you've decided that the US is in a decade-long tussle with China over sort of retaining, a national power advantage, however you want to define it. Is this threshold the right one? I mean, it feels like it's kind of hard to know. And there's a piece of it where you read these regulations where they say, look, this is really what matters most for, nuclear, ballistic, whatever technology. Kind of unspoken is that this may be also what matters most from a sort of economic, commercial competition perspective. Yeah. Curious, Jay and Doug, your take on whether where they set the line is something that, whether if you take US-China competition as a premise, you would have set the line here or maybe somewhere else.
This is Doug, by the way. I thought what Martin said about not trying to cut off their future, but actually we're clawing back some steps is a really good observation. Never thought about it that way, because when you read it a little closer, it's actually extremely arbitrary. So one of the first premises of the regulation is we're cutting off AI and HPC, and then they talk about we're going to cut off their ability to buy and make, buy from TSMC, et cetera. And they're also going to cut off their ability to be able to fab these kind of chips in the future. But if you go and do a closer look, a lot of the same technologies that they're using are actually technologies that are used in 28 nanometer and even 40 nanometer. It's very backwards looking. So, for example, some of the metal deposition stuff is so broad and so encompassing that a very broad application of that would actually would be able to put a stranglehold on a lot of even some lagging edge technologies. So I thought that from that perspective, it actually seems a little bit more punitive than in the past. If we think about this, we're talking about the normative stuff. This, in my view, that this is kind of the zeitgeist has been doing this for a long time. From ZTE and Huawei to now, this is just the same story on a continuous escalation path, right? But now it seems like this time it's different. It's much more punitive and it's more broad. They start with the assumption that you're not good if you're on the list. Presumption of denial. So all this really, to me, in terms of if you read it and you're really fine combing it, there's a lot of discretion, and it seems like the discretion was intentional so that there's a lot of levers to pull. And I think that's they kind of have this stated purpose of AI, but then if you do the analysis a little deeper, you're
Right.
well, it could actually be almost anything. So
I think that was what really struck me was, I lived in China for 10 years, and I'm not an expert on China's legal system, but my interpretation always in China was that pretty much everything is illegal, no matter what you do. And it's just a question of what they're going to enforce and who they're going to enforce it upon. And I really got that same vibe from these restrictions. Here's a whole bunch of very broad rules, some of which are incredibly precise and some of which are maddeningly broad, like AI. That's huge.
yeah,
Right.
what does that mean?
And that goes back to my earlier question was, what's the ultimate goal here? Is the goal very narrow? Do we want to limit the PLA's ability to acquire advanced chips? Okay, that's one goal. Is the goal to cripple China's semiconductor industry? Is the goal to hobble China's overall economy? Right, and those are three very different goals, and it's depending on what we're aiming for. Those rules are going to be interpreted in very, very different ways. And so I've always been very curious what the government Department of Commerce and all the authors really what their intent was, because it's not clear from the documents. Because I know what the Chinese government thinks. The Chinese government thinks it's the broadest, worst possible one. We're trying to hobble China's economy and growth. So that's how they interpret it. How are we really looking at it? That's going to answer a lot of the questions about how these rules are going to be implemented.
And there are layers of objectives in play, right? And there's another objective in that list, which is clawing back market share in areas where the US is feeling some serious angst, like in memory, as we're seeing, right? I mean, that's probably the hardest hit. And both, from especially if you're looking at a medium long-term perspective, that SK and Samsung being at the mercy of BIS licensing, which is a really uncomfortable position to be in, especially when you don't know what is in store for you post 2024, right? You've got to start making longer term decisions now. And China's, by the way, going to be paying attention to that as well. The US is clearly trying to steer production out of China. It's signaling hard through real moves that now's the time. And usually, what is that timeline? It's a 3 to 5 year usually is what you hear back. Give us the time to adapt. So interesting also from a retaliatory perspective, as companies start to restructure their supply chains and mitigate risk, does that also make them bigger targets as we get into that 3 to 5 year time frame?
Before we get to the retaliatory stuff, I do want to talk a little bit about memory, because a lot of the justification within the regs was talking about supercomputers and sort of missile modeling or whatever. I don't think you need fancy memory chips to do that.
You do not.
Memory is kind of a commodity, right? They're interchangeable. Yeah. That Apple can go get it from YMTC, they can get it from Micron, they can get it from Samsung. So if that's the stated purpose, then it's just like it doesn't make any sense, because everyone needs memory. Every logic device has memory on paired to it. So it seems kind of arbitrary, but there is a good statement. There is like a good like you could maybe make like kind of a logical assumption, because memory is one of the things that really matters for AI, especially DRAM. And so you're like, well, we're going to cut off the memory latency and better memory, because that's really important for the entire model's AI model computing power. So that's like maybe a logical thrust, but then how they actually implement it seems much more punitive.
There's an interesting point here, which is that the really big gun, which is the foreign direct product rule, was not applied to the memory, to the DRAM, to the logic chips. It was only applied to the AI chips specifically and the supercomputer controls. So like, why my understanding of the rules, as best I can gather, is that you can't use TSMC for the really advanced stuff, but for like the NVIDIA chips and everything. But with the other stuff like the memory and even a 14 nanometer, that's still going to be fine to fab at TSMC, is my understanding, because they're not applying the foreign direct product rule. It's only a restriction on exports from the United States to those places. So I think they on purpose applied a different level of control based on how concerned they are about the military implications of these chips. But then there's also mixed in with this a sense of economic competition. And this, I think Kevin alluded to this in the podcast you did with him earlier, Jordan, where this seems to be a move back to Cold War style thinking. And I know this is something that Chinese insult the United States with, but it was a long-standing US policy that we wanted to keep, in general, a technological advantage on foundational technologies ahead of the Soviet Union and ahead of China. And for sometimes we wanted a bigger gap between us and China because we were concerned about them exporting revolution. And so now they're arguing that you can't really differentiate anymore between what's important for commercial and what's important for the military side, and they have to control it all. So then some of it's going to be specifically targeted to military applications like the AI stuff, and others is going to be more, on the economic competition side and kind of supercharging the CHIPS Act, maybe.
I remember just a few years ago, like the MilSiv fusion as like the be all end all conversation, winner was kind of like people rolled their eyes at that sort of thing. And to have it be so, put front and center by a centrist Democrat, just gives me the sense that like, this is this policy and this outlook towards China, whether or not it's accurate, is something that is going to be locked in for a very long time to come in the sort of American discourse and policies around these things.
Well, I think if that's all true, then we have to come to grips with the fact that we are, I don't want to be bombastic about it, but this is essentially, economic Cold War, right? Because if you start talking about broad limitations to civil military fusion or, civilian use, military use, civilian technology, then you're talking about cutting off large parts of China's economy, some of its most successful sectors, right? The internet, the Super 7, the hyperscalers, Ali, Baidu, Tencent, those companies are going to get impacted by this. You start looking at the automotive sector, there's going to be potential for big impact on automotive as well. And I think you start talking about hurting those industries, that's a whole different ballgame than cutting off, missiles and supercomputers.
Which is why both the implicit and explicit objectives are really important to parse out here, right? So there is what's striking about these rules is where it talks about, advanced semiconductor thresholds. It basically creates a leap that basically says advanced semiconductor thresholds defined at 1614 nanometer below, non-planar transistor architecture, et cetera, et cetera. It could be used in a WMD application. Right. So they could have set that threshold at sub 10 nanometers, sub 5 nanometers. There are all different ways you can define this. And they chose, a pretty hard line there of where China's already developing. Right. So that seems very intentional in terms of that freeze in place. And that WMD justification can be applied quite liberally just in the way that these rules are written. And Martin, to your point on foreign direct product rule, I think there's a window that the U.S. is signaling here to say that this is where we're defining those thresholds. Now, our tech partners and Chip4, TTC, et cetera, follow suit, or else, look, there's political will here to resort to extraterritorial measures, as we're seeing in other aspects of how the U.S. person's activities rule is being applied here. And in terms of where FDPR was used, right? So I think this is really like a test now of how other partners will choose to align. And of course, there are going to be gaps. I think the U.S. understands that. But I think the U.S.-Japan relationship is probably going to be the most important to watch here, where there does appear to be some alignment, at least on strategic intent. But this is not the way other countries like to design their export controls, right? This is a much more creative, novel approach to it.
And also something we're talking about the intention. I think something that's really interesting to me, at least, is the timing. Something that I've been talking to a lot of people is, what is the retaliation in an economic, Cold War thing? Well, the thing that's so, I guess, brilliant, if taking away the normative side of things, is like the timing is ridiculously well timed. The economy of China is falling off a cliff, and so the historical levers they have to pull back against the United States are a lot weaker, right? If Chinese low end smartphones are falling off 40% year over year, which it seems to be the case right now, and automotive sales are going down, how much more can they cripple you? If sales are going down 20% and they're like, okay, now we're not going to purchase things. Sales are now down 50%. Like, the magnitude of the lever they have to pull back against the United States feels a lot smaller because of the timing of this, mostly because of the zero COVID and economic problems going on in China right now. And so if we're taking it from a purely logistics standpoint, I think the timing of it was really well done from the American government. That's speculation on my part.
I actually have a smaller sub question about timing. Did they know that they were going to release the rules right ahead of the party conference?
And if you read the regs, they kind of feel rushed. They don't feel like they do feel very broad and precise at the same time. So I'm not like, wow, these guys have been thinking about this for years. And then also we did a press release on Monday right after the Congress party about national security things. The timing doesn't seem and this is speculation, to be clear. The timing seems somewhat intentional. That's my opinion.
It seems like there was a big lead up to this, though, right? We had a lot of
Mhm.
clues dropped over the summer. The is
Yeah.
informed letters to AMD, NVIDIA. Sullivan really cr- uh, set out the sea change in policy. Of course, there's midterm political timing. A lot of different things in play here as the U.S. is trying to get ahead of this. So,
Yeah.
lots of different drivers there probably to factor.
Yeah, I mean, what folks in the administration have told me is that we didn't plan on this being like a, giant middle finger to the party Congress, but look, this is how it landed, right? And them telling me that does not change how it's going to be perceived in Beijing.
Right.
So anyways, let's talk a little bit about potential retaliatory measures. I wanted to come to this this paragraph that you wrote, Jay, a little while back, talking about sort of future levers that the Chinese government may have. You write that we have to be cognizant that China is starting to develop industries where it occupies higher strategic ground, albeit not in semis. Those include areas such as industrial systems like machine tools, lasers, robots, electrical power systems, batteries, and more. These are not as glamorous as semis, and Chinese companies still have some ways to go. But somewhere down the road, they may become strategic enough to provide China with a little boost of leverage it does not have now.
I follow it. I follow venture investing in China pretty carefully, as close as anybody can from this removed. And there's a lot of activity in some important categories like those. You look at machine tools, robots, lasers, those are all important industrial tools. And China's actually done really, really well in developing those. Anything around the manufacturing systems. China's gotten very good at manufacturing, and that includes, tools that go into that system. We don't necessarily import a lot of those today, but they do a lot of export business in those companies. Batteries, like you look at CATL is investing in batteries all over the place, right? And in this country, we're obviously, or everywhere, we're talking more about electric vehicles and electrification of everything. China's very, very actively involved in a lot of these important things. They have a lot of battery capacity, and I don't think we're seeing the same level of investment in the U.S. or anywhere else from what we're seeing in China. This week, CATL is talking about trying to get Tesla as a partner, as a customer. What happens 5 years down the road when China's been investing heavily in dirty, polluting battery factories that are then going into clean vehicles? They're going to have that capacity, and we may not. And I think, taking a step back, my bigger concern than the restrictions is what kinds of steps is the U.S. government taking to encourage developing all these new technologies. And that's an area I would love to see them do more constructive work on. CHIPS Act was a start, but there's a lot more that the government can be doing. Sort of more positive, the sort of more constructive side of we're going to, go toe to toe with China. What are we doing on the constructive side to help our new industries, new technologies emerge?
So Doug, say you're sitting in MIT and you want to screw over American microelectronics. What's in your playbook, and how are you weighing the advantages and disadvantages of the various paths?
First, I think I would look at everything that's done in Hong Kong first and foremost. There's actually a lot of distribution done there. So I know that's kind of been already called out by some of the companies that they end up doing a lot of distribution, like kind of like the logistics there. And then packaging is probably the place that China has a relative advantage to us compared to the US. Like there's no packaging done in the United States effectively. And like I would love to see that changed. But and this includes advanced packaging, this includes not so advanced packaging, but they're like at the end of the day, whenever you make a semiconductor, you still have to put it into a PCB or whatever form factor you want to then make the device. Like there is an intermediate step, and obviously that intermediate step is a lot lower value than let's say actually fabbing the chip. But there is a huge choke point there, and I think that they could probably flex that. But I think the problem with that is that if you pull that lever really hard, OSATs, what is it? Something testing and assembly, outsourced something at outsourced testing and assembly. Yeah.
Yes.
Yeah. Cool. Sorry, I forget my acronyms all the time. And so like if you really push that really hard, OSATs are not like a crazy business. It is a little human capital intensive. So, but like you could pull that lever and move that to Malaysia or Southeast Asia really quickly. And so that's like kind of the problem, is that if you push too hard on that lever too quickly, that just further encourages companies leaving their ASAP, which is already happening to a certain extent. People are diversifying their supply chains away from China, and that's mostly through other Southeast Asian countries, which are lower cost anyways. So that's kind of like the problem, I guess, if that makes sense. So yeah, maybe that will hurt in the extremely short run, but that will be a Punic victory in a 3 or 5 year period.
I mean, the bottom line is China doesn't have a lot of great levers to respond with anytime soon.
Yeah, I mean, it just underscores the unreliability factor for China, right? And at a point of extreme economic weakness, which is probably what went into the timing as well for the US and unleashing this as a barrage of controls, right? It wasn't incrementally trickled out by any means. And so when other areas though, maybe less just obvious or explicit is just the anti-competition element. So when we look at China's long arm tools and the arsenal that it's built, there was an article recently where China was basically congratulating itself on building up these extraterritorial measures, and obviously it wants to mirror the U.S. In that kind of leverage, but it doesn't have the same punch, not even nearly, not even close, right? So anti-foreign sanctions law, that's really been just symbolically applied and to entities that really don't have a whole lot of exposure in China. So if now that the US is moving to next level tech controls on China, if China does take the gloves off and targets companies that are more exposed in China that face more domestic competition, that would be interesting. And I think it's a real risk that we have to look at. But in the anti-competition realm, SAMR has had real leverage, right? A real ability to disrupt M&As. And if you look at that in parallel to the US-led friendshoring current, where inevitably this is going to involve tie-ups and all kinds of deals to coordinate supply chains and get more vertical integration. And this is where, you could see some movement from SAMR as some big deals come on the radar.
What questions do you guys have for each other?
I have questions, not necessarily for the group, but the 3 things I would love to hear from the people who wrote the regulations, right? Which are in crafting these rules, which agencies showed up and really did their homework, and who phoned it in? Because it feels like some people did more work than others.
Yeah.
Right. And
How so?
And then,
How so?
well, we were talking about it earlier. Some things are incredibly specific, like the rules around AI performance. Like they specify TOPS, TFLOPS, like really, really precise numbers. Like who came up with those numbers? And other areas, it's just like supercomputers.
Yeah. A good example of place that I feel very comfortable, they go ham on metals deposition. Like they don't talk about
Yeah.
etch tools once, but they talk about metals deposition, like 14 different types, the different types of metals, the different types of like processes. They go like in depth on ALD, and then they don't talk about etch once, and you're like, what the hell? Like this is really weird. Whoever did the etch part of it, like, mailed it in, and whoever did the deposition, like became an industry expert, because I was like, wow, this is very comprehensive. So I thought that was like interesting. I mean, that's like kind of the reason why I guess I feel, and this is like maybe a vibes thing. The whole thing feels a little rushed because it, like, when you read it, it feels like very disjointed, right? There's like the metals deposition part was just like mind-blowingly specific, if that makes sense. And then they talk about like ion implantation, which is something that I know a little bit about, and I'm like, this is so vague, it could mean the entire set of tools that have ever been made. So it doesn't like, it just kind of that's something that I really am curious about as well.
What it might be is like there is someone in the national labs who knows, who really knows something about X, and like they actually just couldn't find someone in the system to help them get up to speed about Y. My guess would be it's that sort of thing, as opposed to like a grand strategic thing or like some person mailing it in. It's like there's just expertise, like there is limited expertise in the US government on this stuff. And I think it's probably pretty spiky for certain things and not others. And, whoever's job it was to write this had, a really good contact within the system that they could trust to help them write this sort of stuff. Again, this
So-
is speaking
So
not from any
that actually,
knowledge, but
that actually leads to my second question, which is, I think Kevin on your show last week, he was really clear that the rules, the timing between announcement and implementation of the rules that window was deliberately very, very short. And I understand they had valid reasons for keeping that window tight, but it's the kind of thing that opens up all sorts of unintended consequences. So in the rush to get the rules out, there was no consultation or very little consultation with industry. And so my question now is, when the authors were putting this together, to what extent did they war game or think through some scenarios of what's going to happen next? Like, did they actually do any wargaming or planning, or did they sort of say, "Oh, that's going to be unintended consequences. We'll see what happens. YOLO."
There's a great line in the SME section, which it basically says, the urgency behind this basically makes us or has led us to implement these, effective immediately. But we'd love to hear what you have to say about it. So send us your comments.
That's right. That's right.
Which I thought that was very cleverly phrased. Obviously, I'm paraphrasing here, but it's not too far off.
That's right.
Yeah.
And so it also kind of raises a question in the disparity of, how much quality industry input was coming from the tool makers versus, the chip makers, and designing a policy like this. And you definitely see some gaps there just in terms of that two-way communication and not a whole lot of voice coming from the SME front.
I've heard it's even further than that. I've heard that it was deliberately, they wanted to keep certain industry bodies out of the process because they have
yeah,
a lot of lobbying weight.
I was gonna say, so on the Lamb, so I've been like, I follow the earnings calls. The Lamb research call was despondent. Like the management
Yeah.
team was despondent. Like there's no other way to put it. They definitely were like, we had no say in this. This is going to hurt the crap out of our company. We can't even quantify. We have no idea. Like we're so flat-footed. We're so offsides. No one really gave a heads up at all. Like that's at least my vibes reading of the whole thing, because they really are just like, we don't know. We'll try to quantify it. We're struggling to quantify it. We can't quantify it today. Like it sounds like no one gave them a heads up at all. And then, I mean, at the same time, I think Pat Gelsinger is out here doing he's out there,
Somersaults.
he's doing somersaults. He's doing a press release. He's like doing interviews and stuff. So it's like, I'm sure Pat was definitely in on it. So it's like this weird, there definitely seems to be a very difference in where I'm guessing the more punitive it is, the less they talk to you, unfortunately. Their biggest lobby was the 1 year temporary license, which I thought was really crazy. They're like, hey, I know that this could mess up supply chains. Here's a 1 year. Here is we granted temporary license to these South Korean companies, and then that's already been extended to a 1 year. But it's like, it's shoot first, ask later, and here's a temporary license that we can use as a way to draw, to fix ourselves, but also continue to have leverage. Like it's very, you're right. It's very different in tone.
Yeah, now there's just an interesting dynamic in play here where obviously BIS is creating a lot of work for itself, right? It's ballooning regulations. It's severely understaffed already. So you could take that and infer that, well, there's no way that this can be enforced adequately. On the other hand, when you have limited resources, you make an example out of companies, right, to draw broader compliance. And we're in an interesting phase right now where we're coming off, CHIPS Act funding passage, and all of that is now in play in the implementation phase. And the government probably feels like it has some leverage, right, considerable leverage over the major recipients of those funds to comply, that these are the conditions attached, that there is intent to steer production and high performance computing chips away from Chinese access. So yeah, that kind of push and pull. There was probably a lot of going into government assumptions and coming out with these controls now, and then expectation on compliance, because there's an acknowledgement in these controls that this is hard. This is really hard to get the technical thresholds right. Civil military fusion is just really, really complicated for regulators to wrap their hands around. So guess what? We won't, right? The US is basically saying, the onus is on Chinese entities to demonstrate their bona fides, or else, guess what? You're on the unverified list, which is a shortcut to the BIS entity list, or worse, if you end up getting FDPR'd. And there's also a compliance burden shift to the companies to say, look, we're saying advanced semiconductors could have WMD application, full stop. Now it's up to you to basically restrict yourself based on these guidelines that we're giving you.
I think that CHIPS Act leverage is a really, really good point. I hadn't thought of that. It's a really good point because I, I mean, if you look at all the stuff that's happened over the last 4 years, starting with Huawei and ZTE, the biggest force working against all the government's rules are U.S. companies themselves, right? That's where the loopholes are coming from. That's where the army of lawyers looking through all the wording and parsing every word of all the restrictions is very strong. And I think the authors of these latest restrictions were very cognizant of that fact, and now we're going to see how it actually gets implemented, because we've already had a bunch of waivers go out. Like I think Intel got a waiver, a bunch of other companies got waivers very early on. They were consulted. Now I'm watching to see who else gets waivers. Does KLA, Lam, any of those companies get significant waivers? Because ultimately that's going to, we've been talking before about how the devil is going to be in the details of implementation. And a big part of that will be how we treat the U.S. companies who want to continue selling different products. I mean, here we are 4 years later. 4 years later, Huawei is still shipping base stations and phones, right? They've, not a lot of them, but they're still able to do it. And they're sourcing U.S. parts somehow.
Jay makes a really important point about the firm's response to these restrictions being crucial. But I think we should also interact them with the inducements that the U.S. has also put in to the CHIPS Act. So the firms that have agreed through receiving funding in the CHIPS Act and setting up more semiconductor-related activity in the United States have already agreed to guardrails that they're not going to expand and in some cases upgrade their semiconductor activities in China. And these restrictions could, in a sense, supercharge that by making those decisions even more clear for them, because whether they accept the CHIPS Act funding or not, they won't be able to make those investments in China, because they probably will not be able to get the most updated advanced equipment going forward if they only have these potentially shaky waivers in the short term. But they could also, in a sense, undermine some of the CHIPS Act inducements to bring firms to the United States, because you might decide, if you're a firm that it has a lot of business in China, that you would rather excise as much U.S. technology and U.S. components from your equipment or supply chains or other processes as possible, so that the U.S. can't have any of this long arm jurisdiction on you. So I would love to ask Jay and Doug what you think the prospects are for firms doing exactly this, which is managing to get so much U.S. technology out of their products that they're able to continue to sell to China, even if the U.S. tries to put something like FDPR on them.
So something that's really weird about semiconductors is that in a lot of ways, the ways that semiconductors have been made is almost identical to when they were made, essentially when the industry was birthed 50 years ago. Essentially, it's almost all the same steps, but just miniaturized. And so that's one of the reasons why America has so much long-term IP, because they invented it and it's almost the same, just a million times, a billion times smaller, something like that. And so that's like kind of the hard part. It's really hard for you to step out of the, just because semiconductors are a very cumulative effort. It's taken so long to get here, and it's been a village, right? A good example is ASML recently on their earnings call said, "Hey, we are not going to be as impacted by this because we're a European company. We're shipping European goods. Maybe we'll have some spares in the U.S., but I'm almost positive that what's going to happen is that the BIS has a lever to go after them, because one of the meaningful subsystems parts is made in the United States. It's a San Diego based company. So it's like these, it's really, really hard because of how much entrenchment there is. And the one place where you have an opportunity to maybe go outside of the American I guess the moat or whatever, the village of American semicap companies is Japan. Japan definitely is the only, and part of that reason is because Japan was around in the beginning too. And, you know, a lot of these same companies that are competing against American companies were competing against Japan, were competing against them back in the 1980s as well. So, but there's kind of that second level there that Japan and the United States, their relationship is extremely tightly woven together too. So I think that there is ways to eventually get there in some of the extremely more commoditized processes of the semiconductor, you know, fabrication stack, if that makes sense. Like CMP is not the craziest thing ever, and I think that if you give anyone a sufficient amount of time and resources, they could figure it out. But it's going to take a lot of time and it's going to take a lot of resources, and that's before we even have a working product. And so there are some places where I think there's a potential. But you know, it takes 1,000 steps to make a semiconductor, and you're gonna have to get and a lot of the steps are duplicative, to be clear. But you're gonna have to get them all right. You can't just you can't just really nail your one step and be like, well, now we can make a semiconductor. It takes a village. It takes a lot of parts. Jay, any thoughts on that?
Yeah, I think if you look at the history of this, SMIC, the Shanghai Foundry, has been poaching staff from TSMC since its inception. I mean, for 20 years, and they still have not been able to close the gap. I think there is an important distinction here between technical capability and commercial capabilities, because I'm sure that there is some research lab in China somewhere that can has a small EUV system and can produce 5 nanometer chips, but they can't do it at scale, right? They can't do they can do a wafer a day as opposed to 30,000 a month like the fab
Yeah.
could do.
The
There's a
the
big gap
engineering
there.
the engineering is crazy. Like that's one of the reasons why I love the industry is like, you know, these things are moving around at like I want to say like multiple G's. Like it's very precise. It's all in a vacuum. Like, you know, it's one thing to make one wafer, but it's another thing to make thousands of wafers with 99.999% accuracy over and over and over again. And that's like
Yeah.
the real problem. And that's where this is a cumulative benefit is like, hey, if this is all you've ever been doing since the 1980s and you owned the market back then, you own the market today, all that cumulative knowledge and experience comes with you. So
Yeah.
that's kind of the hard, that's the real hard part.
I think this really speaks to the bigger challenge China faces. Is it's not just about point technology. It's about processes and management systems, right? You look at TSMC and ASML, like the real choke points in leading edge. Those two companies are very good at managing incredibly complicated systems. Like that's their real expertise. It's not the machine itself. It's the way they organize all this activity. And having lived and worked in China for a very long time, I think this is an area where China really struggles, is sort of management practices and management philosophies. Like, remember when Japan, you all probably too young to remember this, but in the 80s, when everyone was worried Japan was going to be this rising star and eclipse the US economy, we actually adapted a lot of Japanese process technologies, management philosophies like Kanban, things like that. We brought those into the US. There are all kinds of books written about it. You don't see the same thing happening with China's rise. You don't have, wolf management skills being adapted into US tech firms.
We should. I have on my wall. There's like Huawei's written a few of these books. And well, I mean, there are a million of these books in Chinese, but they've translated a few in English as well. I do want to come back to this idea of, okay, you can do a wafer a day in a lab. If you can do a wafer a day in a lab, you can probably make enough for your missile systems. No? And if so, like, then it really is just an economic competition.
Well, I was gonna say slight pushback. I mean, you can make some wafers, but okay. So even a good example is right now. There's actually there was a really good article I read the other day talking about how Russia is forced to import Chinese chips in order to support their military operations, and the effective yield of that is like 60%, meaning 40% of the chips that they're making have defects. And this is like lagging edge technology. This is not rocket science at all. This is tools available, like presumably from American tools with processes, like stuff this is a solved problem, and they're having 40% defect yields. I mean, yes, maybe you can make some artisanal handmade rockets, but it just doesn't. We're looking for scale, right? In a real, it's all about your total manufacturing at the end of the day, and you can just it just won't be the same. Even if you do it in batches or whatever, we're talking about, the entire output of the entire academic system, making batch wafers would be equal to like 3 hours at TSMC. So, Jay.
But to your broader point, I do think that our ability to really restrict the PLA from getting advanced chips, it's going to be a big struggle. I think we're going to have a very hard time doing it. It's just the supply chain is so porous. They're not going to need to go to the academic institutes in China. They're going to get them on the open market through dozens of shell companies and complex distributions channels.
Yeah.
Right.
Yeah. How many
And
of these chips get sold a year?
Yeah, millions. Yeah, and then the other thing too is like, okay, so I understand the AI part of it, where like that obviously needs a high-end A100, H100 chip from NVIDIA, but like missiles do not really need that, right? Like most of this is like my understanding is FPGAs are like the du jour product for military applications, and a lot of times I don't think they're cutting edge FPGAs. Like a 28 nanometer FPGA is probably more than enough. You could just like throw more of them in there. It's not like it takes a ton of space. And so that's for like missiles, I guess. I'm gonna guess that like AI stuff where it becomes truly, technologically crazy is a different story. But I don't think it really requires that much in terms of it's like an engineering problem. It definitely makes it a lot easier if that makes sense. Like if you had a leading edge FPGA, you'd be doing a lot more. It'd be a lot better and a lot easier. But I don't think this is where like you can't just really stop that altogether. Like the technology is mature enough.
Yeah, I mean, maybe it's like some super classified future war things that
Yeah,
is where this stuff matters.
Yeah, I think if we look at it in the context of Ukraine, where there are a lot of tactical munitions that are now smart, all these HIMARS systems that have guided munitions in tactical launchers, that's a much bigger volume than if we're talking about strategic cruise missiles and ICBMs. Because I think Doug's right, for those kinds of things, you have a lot of space in the vehicle, so you don't need very small chips, and power is less of an issue. But if you want to do it at scale, where you sort of give every infantryman 1,000 smart munitions, then space and
Every bullet's smart, every bullet's smart, every rocket's
Right.
smart,
Well, so well short of the military application here, there's an interesting kind of underlying policy debate here of should the U.S. maintain and grow a strategic one-way dependency with China, meaning that China remains highly dependent on the U.S. for critical inputs, especially for mature technologies, that go into more commercial spaces. And even in the CHIPS Act guardrails, there was a provision in there that basically said, okay, we're saying don't, increase production in China. It set the threshold at that point at 28 nanometer. But it also said something to the effect that if you're going to be producing in China for the China market, that's okay, at that more mature threshold. So that gets undermined if you go too far with your controls, right? Because once you get to an FDPR level control, you're getting to a level of blacklisting that undermines that strategic one-way dependency argument. You're not going to be able to sell to those Chinese entities. You're not going to be able to grow that dependency, right? And I think that's just something that I don't hear talked about that much in the longer term policy debate. But it seems like a critical question to contemplate on what the U.S. wants to get out of this.
I think it's very interesting that in all of this, there is this presumption of success on behalf of China's semis complex. Like we're assuming that, they have this incredible capability. They're very, very capable. And I think in some senses, the opposite is true, right? Over the past decade, they spent $100 billion plus, and they have not actually advanced their ability to manufacture chips at all. The gap between SMIC and TSMC is just as wide as it was 10 years ago. The domestic wafer fabrication equipment industry is not capable. They don't have EDA tools. They've had a lot of success on the fabless side, lots of thousands of companies doing chip designs, but they're all as dependent on TSMC as everyone else. And so there is a reasonable argument to be made that, hey, if your adversary is making a mistake, don't stop them, right? If they spent $100 billion last decade, let's see if we can just let them keep going and get them to spend $200 billion this decade.
So I do agree that it's been very hard for them, but I want to push back a little bit on the struggles, right? Because YMTC is a perfect counterexample of that, right? Where they really do have a technology roadmap that's as good as the Western companies, essentially. But at the same time, I also think that the SMIC has had some grenades thrown in their process along the way. So like, I really wonder if SMIC had no export controls, the Huawei thing never happened, they never were ever stopped, if that makes sense. Would that gap be shorter? I think yes. I mean, like historically, if you look at the catch up of Asian economy, so like there's actually a really good book on this if you're interested. It's extremely academic, but it's called Tiger Technology. It talks about
Oh,
each
yeah.
decade. Each decade of semiconductor countries essentially catching up, and the playbook is the same. The government heavily heavily subsidizes loans, does all kinds of stuff to prop up a semiconductor industry. They make tons of losses, are meaningfully behind, but they close that gap, and then eventually, ever so slightly, they become a leader. So this happened in Japan, obviously, then Korea, then Taiwan, and so that, like, China literally just found the playbook. They're like, let's do it. They're applying the exact playbook, and I know that it's been very hard because honestly, this like is a post Moore's law era. Things are getting harder in fabrication, but I don't think that given infinite time and infinite resources, they wouldn't have done everything else that history has done as well. So I don't know, somewhere between those two. I do agree. There's a lot of failure in the process. Like there's been a lot of high profile failure for Chinese semiconductor industries.
So I agree with that economic framework in the Tiger Economy's book, but there's a key step there, which is they can close the gap, but actually transitioning to being a leader is much harder. And the number of economies that have actually founded on that is very long. You go look at sort of long-term historical economic history, that transition from a the middle income trap and being able to transition then to becoming a world leader is very, very difficult. And there's no I don't think it was guaranteed that they would succeed. Because like I agree, YMTC, hugely capable, incredible product. They got what, 20 billion, 30 billion in subsidies?
Mhm.
Right? Name the second one. What's the next company we put on that list?
There really isn't a second. That's the thing that
Right.
makes it so interesting, because and then like right now there's actually a whole profile of news of like there's a lot of pushback, like people are getting axed essentially because of their high profile failures of being given billions of dollars and having essentially nothing to speak of it.
Not axed, arrested.
Yeah, sorry, arrested and going to re-education camp. Okay, like there's but there's so yeah, I think if we're talking on like a pure capitalism, dollars invested, I don't think we ever thought that China would be like the greatest ROA or the greatest ROE of that capital. Like, I don't think it was ever implied that there was going to be a good economic return. And essentially, my thought process is they would earn ROE similar to the SOEs, which is like, low single digits, right? So as long as they hit that required
Negative.
rate of okay. So
Negative.
the publicly listed, I know they're negative, okay. But like, I mean, I think there's like 3 that have like 2% ROEs or something, which is that's horrendous. But anyway, so like, hey, if you got a 0% ROE on $100 billion for the Chinese semiconductor industry, I think the state would be okay with that. And that would be considered
as long as you can deliver the goods and you get
Exactly.
your global market share and you're able to sort of help out the PLA when they need it. And that's not quite where we're at. And getting there is going to be more buckets of tens of billions of dollars with a definitely uncertain future of whether or not this is even possible.
The roadmap looks to be getting harder, especially after the export controls, for sure. There was definitely a shot, a hope, a chance. But we essentially have totally cut off the next 5 years window, I think. Is that fair?
Yeah.
Not 10 years?
5, 10 years, yeah.
Is there an opportunity here for U.S. firms to take advantage of the talent displacement caused by the regulation around U.S. persons?
So in the short term, it looks like the semi cycle is definitely beating out the long term. Because I mean, 1 year ago, everyone's biggest problem was we don't have enough talent. This year, it looks like there's already variable cost cuts. Intel's probably going to do some layoffs. Like there's already things are coming down the chain. Something I think that's actually a little interesting that I've put a lot of thought about into is that in the United States, the actual fabrication process is actually very concentrated in essentially Intel. So there really isn't a market, if that makes sense, versus TSMC. And TSMC obviously is the market. Like in the United States, there really isn't a lot of competitive workplaces. Like it's Micron or Intel, and essentially you're going to be going to either or. And so I think that's like kind of a problem because it really stymies the like extremely, I guess we'll say like ambitious ones where it's like, hey, I have some versus it's like you're going to be either working for Team Blue or Team Red or something. There's only two choices. So I think that that's something I wish there was more of, is that there's like more actual American fabrication competition so that there's actually more places to work and more opportunity, and it feels like a more vibrant ecosystem. And I think that's like one of the biggest advantages of Taiwan, that there just is such a deep ecosystem that the United States doesn't have.
Closing thoughts?
My main kind of long-term thought on this is just where we are on the escalation ladder, right? Parallel to this is the Taiwan escalation ladder, right? And now we have the tech control escalation ladder. And those two cross over in really interesting ways. And so when you just think like kind of in a beyond 2024 scenario and how really potent rules, under the IEPA national security umbrella or under this, new package of BIS export controls, how those are applied really, really matter. You can take a precision, approach, or you can take a really blunt approach. And if you push China toward an existential crisis, that could have some really, really big effects. And I think that's something that weighs heavily on the minds of U.S. partners. Japan has experience with this with the U.S. If you look at history and being pushed in a corner like that, right, and what you resort to and situations like that. And I think Europe now looking at the war on its own continent, right, is really, really hesitant to push China this far when it's already dealing with some what looks like 20th century problems, right, creeping into this century. So that's kind of the longer term concern that I have.
Yeah, I mean, I think it's very much still an open question whether this stuff raises or lowers the chance of conflict.
I think Riva raises the key point in all this is what comes next is very important, and the escalation ladder. If I were to pick a second order priority for me is, now that we've just bought ourselves a 10-year window, what are we going to do with it, right? Are we going to push, are we going to spend all this money pushing lagging edge technologies, or are we going to actually try and invest in things that matter, things that are new, right? That's always the drawback of a planned economy, is you're building last century's, railways and hydro plants. What are we going to build for the 21st, 22nd century? Power systems, quantum computing, new models of compute. That to me is, how are we going to spend the next few years focused on beating China, or focused on building what's important and what's new and what's coming next?
Anyone got a song? Come on, chip song.
I don't have a chip song, man.
How
I got
big an
nothing
industry
for
do
you.
you have to be to get a song? I mean, this is ridiculous.
I don't think it's a question of size. It's kind of a question of,
Cultural.
personnel dynamics.
Okay.
Very
I've
lightly
worked in-
phrased. Yeah,
right. I've worked in semiconductors for a long time, and I'll go visit my friends who work at Google and Facebook and Twitter with their in-house massages and their 27 free cafeterias. They can have songs. I'm just excited when the employer has a coffee machine and the.
Thank you so much for being a part of China Talk, everyone. This is a lot of fun.
谁说也许你会爱上的情歌，在你的自动播放清单的情歌，也许有天会听到这首情歌。Please tell me how you doing, how you doing. 也许你会爱上的情歌，在你的自动播放清单的情歌，也许有天会听到这首情歌。Please tell me how you doing, how you doing. 咨询你 Happy Birthday。已经是1个多月前 ，Still got no reply。明白一切回到原点，没有你的消息我还在等待。渐渐变得小心你的 give a try。 3更半夜，房间亮着他的 reference， 听着记忆上的他声，脑海里浮现你跟着唱的脸，睡下的天空，连房间都是你的声音。Oh shit， 上瘾的人放了你的 playlist， 写一首也许你会爱上的情歌，在你的自动播放清单的情歌。也许有天会听到这首情歌 ，Please tell me how you doing。How you doing？ 也许你会爱上的情歌，在你的自动播放清单的情歌。也许有天会听到这首情歌 ，Please tell me how you doing？How you doing？Baby I don't wanna lie， 我们不可能存在。I don't wanna live without you， 可以纵容爱。Crush on you， 唱不出 I don't give up。变路子也不舍得你为我流泪水，你是我宝贝，你没世界愧对，被世界摧毁，也不愿意让你受罪的那种人，连我可怕得很 ，Only me， 下一场长光奔，闭眼神麻烦问你的位置来的有多的好剧痛 ，Oh shit， 上瘾的人放着你的 playlist， 写一首也许你会爱上的情歌。在你的自动播放清单的情歌，也许有天会听到这首情歌。Please tell me how you doing，How you doing？ 也许你会爱上的情歌，在你的自动播放清单的情歌，也许有天会听到这首情歌。Please tell me how you doing，How you doing？ 也许你会爱上的情歌，在你的自动播放清单的情歌。也许有天会听到这首情歌 ，Please tell me how you doing，How you doing？